And we should be going now. Okay. This is geometry, review, 1 through 30. What we'll call as part 1, looking at the actual test. Again, you've seen questions like this. They're going to say something like point Y is on line XZ, something like that. Let's see, they'll say something like XY equals 10x minus 10. They'll say something like YZ equals 6x plus 4. Find segment XZ. That should be really easy, right? We've done stuff like this before. What am I simply doing here? Finding the line, okay? By doing what? Setting them equal, okay? Somebody said setting them equal. Somebody else said, what did you say, Tiffany? All right, so there's a big difference between schools of thought here. Do I set them equal to each other and solve for x, or do I add them together? How would I know? How could I be sure? Do what? Try both? Oh, well, I mean, I could try both, but in the end, I might look at the answer key and see an answer for either one, right? Because there might be an answer for either case. All right, how could I be sure, right? Right, you could only be sure that they're equal to each other if it said y is the midpoint, but it just said y is in between x and z. It didn't say it was in the middle between x and z. Does it make sense? All right, so that was kind of a quick assumption, not necessarily a bad assumption, but there's still one thing I could always do to kind of get an idea of what it is that I should do, which is what? When in doubt, draw a picture. Okay? Okay, here's x, here's z, and we're going to offset y a little bit, right? Just so that we're not getting in our head that it's in the middle and these two things are equal. Okay? We've got, and I'm not to scale here, but 10x minus 10. 6x plus 4, and what we are solving for is that right there, right? Okay, so now that I've drawn it, I should have a much better idea of what it is that I actually need to do, which is what? Add them, okay? So especially whenever we're taking tests, we do have that tendency to make quick judgments, you know, and like because we kind of get in our heads, oh, set them equal to each other, solve for x, plug x back in, right? Because we have to do that a lot, all right? But you do need to slow down enough to actually examine the question. All right, so we're going to add these things, 10x minus 10 plus 6x plus 4. Okay, what is this question asking me to do at this point? Add like terms, perfect, okay? What are my like terms? 10x and 6x, negative 10 and 4, perfect, okay? What's 10x and 6x? 16x, negative 10 and 4, negative 6. Is there anything else I can do here? How? There's no equal sign. No, there's no more like terms. There's nothing else to do. Okay, I don't have any more information. Okay, if they gave me a value to sub in for x, if they told me that the whole length was such and such, right? But I don't have any more information to work with, so this is my final answer. Okay, and that's okay. All right? So sometimes knowing that you're not always going to get a number answer, okay, can set you at ease a little bit. All right. Let's see. We want to find the perimeter of a square. Find the perimeter of a square with a side length of 22. Twenty-two times 4. Perfect. 22 times 4 is 88. Right? And I don't know. They're going to say, let's say if we'd said 22 feet here, we're going to say 88 feet here. Should be really easy, right? A lot of people will still get this wrong because one of the available options will probably be, 22 times 22, right? Solving for area, okay? Or, one of a number of other things. All right. So just because it's an easy question doesn't mean that you won't get it wrong. All right. This next one wants you to find the distance between, let's see, let's pick some numbers out. 12, -8, and 2 and 0. Okay, got to start with what? Distance formula. Okay, so what is the distance formula? What's that? Okay, radical. What goes under that radical? Okay, good. Okay, square root of x2 minus x1 squared plus y2 minus y1 squared. We've seen over and over again how important it is to memorize certain formulas. Okay, what I would do at this point is I would go ahead and label those four values as x1, x2, y1, y2. So then all I'm doing is substituting values in. What is 12? x1, what is -8? No. Okay, but that's right. But the reason I ask you really quick, and I said it the way I said it, is because we're going to have a tendency to go x1, x2 on the same set of coordinate pairs and then plug them in that way. So I wanted you to do that because that's the kind of mistake we'll make tomorrow. Okay, y1. Okay, over here, x2, y2. Okay? Right? We would much rather make those mistakes on review day than to make them on test day. Okay? So x2 is 2 minus x1 is 12. And make sure that you're bringing, that's why I'd write that formula down at the beginning, and then make sure that I am bringing everything down, every little thing. The minuses, the squares, the pluses. Okay, y2 is 0 minus -8, right? Important difference. Okay? All right? 2 minus 12. -10. Squared. Okay, we've got to continue to bring that down. Plus 8 squared. Okay, good. Okay, and because I'm just kind of making up numbers here, this may or may not come out all nice and neat. All right, what is -10 squared? 100. And I'm just telling you that a lot of people, the mistake that they'll make is they'll get down to here, they'll drop the parentheses, and they'll wind up with -100 there. Okay? Don't drop the parentheses. What is 8 squared? All right, so we got 100 plus 64 is easily 164. So this one will have it for simplified radical form. Okay? Let's see. Let's just, and I don't know that they pull anything out necessarily, but is 164 a perfect square? I'm just going to go into my calculator, hit second square root, 164. No, it's not. All right, but I could possibly, and I want you to see how to do this, right? we can find out what the simplified radical is. What was that? That's going to be, what, 82? And that's going to be, what, 41? Okay, I think 41 is a prime. So this would actually be 2 radical 41. Okay, because I get to take out 2 2's, it becomes 1 2. Okay. Okay. All right. So you guys should understand all of that. Let's keep moving. Okay. 4 is really similar to that earlier line that we looked at. Let's see. We will again use X, Y, and Z. They'll give you some information like this being, say, 12x plus 20. They might tell you that this is 70 and that this whole length is 16x. Okay? Now, what they're going to say is find xz. This is a little different, okay? It looks very similar, which is why I want you to be able to write the picture down in the other question. But this one gives us actually more information. It doesn't say midpoint. Okay? 12x plus 20 does not necessarily equal 70. But what does 12x plus 20 plus 70 equal? Which is 16x, right? So I can still add, right? 12x plus 20 plus 70 equals 16x. And I can solve for x in this case, okay? All right? I know that my handwriting's not great, and it's somewhat hard to see the differences between 20 and 70 here, but I should get what on the left-hand side? Can I simplify the left-hand side? Okay, that's going to be what? Okay, so 12x plus 90 equals 16x. We added the 20 and the 70. Now what? Subtract 90 on each side? Not really necessary. Subtract 12x, right? Because right, that's going to get all my x's alone. I got 90 equals what? 4x. Okay, can't drop the x. Okay. Now what? Divide by 4. Okay, 90 divided by 4. What does x equal? $22.5. Okay, I'll take your word for it. 22.5. We're done, right? No, obviously, whenever I ask a question like that, the answer is no, because what do I have left to do? Where? Which one? Okay, so I need to finally do 16 times 22.5, which is 306. Okay. Oh, sorry, 360? Sorry, just going on what you're telling me. 360, okay? 360 is our answer. Okay, so we should get something like xz equals 360. Okay, we understand what to do here? All right. Let's see, you've seen this question before. It's going to give you figure numbers, right? It's going to show figure 1, figure 2, figure 3, and it's going to give you boxes. So it'll show you something like this. Let's see. Okay. Okay, it'll show you that pattern. Okay. And it's going to say how many boxes in the, let's say, 7th figure. Okay, we've only gone to 3. How can we do this? What would we do? How would you go about solving this? Adding 3 each time? From figure 1, I added 2. Okay, so this adds 2, and from 3, right, 1, 2, 3, 4, 5, 6, so I add 3. So I added 2, then I added 3, then I would what? You would add 4 to that, and then 5 to that, and 6 to that. Okay? Could I maybe start with just straight up drawing a picture? Okay? How many squares are going to be on the bottom of the 7th figure? 7. Okay? So it might be just as easy rather than trying to count over and over again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Because I think in this question, they're also going to want to see okay, and then we can count, and it should go 7, 6, 5, 4, 3, 2, 1, right? So that's another way of doing this, is that if I see that the pattern going from the top down, from 1, adding another row, so 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Is that what it is? Okay. So I'm going to go with you on that. Okay, so if we want to know how many we're going to be in the 8th figure, all I would have to do is add 8, right, to 27. Okay? Does that make sense? You look like you got a question. Well, let's check. Okay, and there's 3, there's 7, there's 11, right? Well, that would be 10, and this would be 21, right? 21. 10 and 11. Does that make sense? Huh? Oh, plus 7. All right, so, sorry, 28? 28. How far off were you? By 1? Okay. Sorry, forgot to add that last one. Okay, we good here? Excellent. So it's just being able to identify patterns, but you will need a picture, the correct picture. So they'll give you a couple of pictures that are identical, but the numbers are going to be different, so be careful with that. Okay, let's see, question number 6. Question number 6 is going to give you a right triangle. So obviously, what are we thinking we're going to need to use here? All right, let's say if I said 6 inches and 8 inches, and I wanted to know what the hypotenuse was. Pythagorean theorem, okay? So, what is the Pythagorean theorem again? A squared plus b squared equals c squared, very good. What's the most important part to that formula? The hypotenuse, which is which letter? C. And where is C always on the triangle? It's the longest side, but I don't have all the measurements, so how do I know which side is the longest? Always opposite the right angle. So the one I'm actually trying to find here is C, correct? All right, so let's go ahead and put in, what did you want to put in for A squared? So 6 squared, right? Okay, plus what? 8 squared equals C squared. 6 squared is 36. 100. Okay, good. 100 equals c squared. What do I have to do finally? Square root 100. 10 equals c squared. Answer would be 10 inches, correct? Okay, very good. That's also a Pythagorean triple, by the way, okay, because it's, 3 times 2, 4 times 2, and 5 times 2. If you remember your 3, 4, 5 right triangles. Okay, 7. Making pretty good time here. Okay, now this one, so we've got a lot of line segment stuff in here. Let's go back to, let's say, I is the midpoint of HJ. Okay. Let's see. We'll say that HI equals 12x. We'll say that IJ equals 6x plus 18. We want to find out what all of these segments equal. So what is HI? What is IJ? And what is HJ? It wants to know what all of those segments equal. Right, so if we know that I is the midpoint, all right, but we do have to be clear here, right? Because they could have confused me. If they had said HJ is something and HI is something, I'm probably safest to do what before I start? Draw a picture to make sure I'm looking at the correct segments, right? All right, so we do know this, H, I, J. Okay, HI, 12x, IJ, 6x plus 18. Okay. So now, can I set those two things equal to each other? And the reason I say you want to draw a picture because they could have given me HJ, right, if I wasn't just paying really close attention. Does that make sense? All right, so 12x, equals 6x plus 18. Okay? What do you want to do first? Subtract 6x, okay. From both sides, I take it. 12x minus 6x. 6x equals 18. Divide by 6. X equals 3. All right? All done, right? Substitute. Okay, substitute what for what? Or 3 for x. All right, so what is HI then? What is 12 times 3? 36. And if IJ is equal to HI, what do I already know IJ is? 36. Right? And 6 times 3 is what? And 18 is 36. So that makes sense. And what would HJ be if HI is 36 and IJ is 36? And you would get? All right, so you have those measurements, 36, 36. Okay? Does that work for you guys? All right. Okay. All right. Let's see. This one is going to come back to that lesson 12 stuff. So it's going to look like this. Let's see. If I have angle 1, angle 2, I've got line A, B, and C. How can I prove if angle 1 is congruent to angle 2? How can I prove A is parallel to B? What theorem or postulate can I prove to say that line A is parallel to line B? Okay, two lines cut by a transversal, what? No, not necessarily. Let me show you two lines cut by a transversal that are not parallel. Okay, so not all two lines cut by a transversal are parallel, correct? All right, so you're correct in saying two lines cut by a transversal can be parallel, but I have to have more information to go with it, because right now you haven't included anything that involves angle 1 and angle 2. No, they're not adjacent. They don't share a common vertex or a side. Well, we already know they're congruent because my statement says they're congruent. Right? This is why we're failing from lesson 12. Remember, I gave you a list of things, and I said if these things are congruent, then we can prove that two lines cut by a transversal are parallel. So you need to go back and look at lesson 12. All right? Anybody remember what those list of things were? There was alternates. There was same side. There were corresponding things. Right? Okay? You're going to get a test tomorrow. So, I mean, I know the answer, but it's not going to do you any good for me to tell you what the answer is. Right? You're going to have to dig in for the information. Okay? You have to learn it. I already know it. Okay, I'm going to move on. All right? This is something you need to study. Lesson 12. You need to study lesson 12. You've seen this question on multiple tests up to this point. Okay? Okay? You're going to get another question that's not too dissimilar from it right after it. Something's going to look, let's change it up a little bit. Let's see what happens if I do this. Try to find a number that's going to work here. Oh, that didn't work. Well, may have to use some original numbers. Okay. Okay, this one wants you to show that lines A and B are parallel. Means, well, not only are these interior lines, you're correct, but they are, no, they're not adjacent. All right, let me show you what adjacent angles are, because I feel like we kind of like keep throwing that statement. Okay, this angle is adjacent to this angle because they share this point and that side. Okay, that's what makes two angles adjacent, is if they share a point and a side. Okay, and these two angles don't do that. Does that make sense? They are alternate and they are interior. Okay, and if alternate interior angles are what? Are congruent, then two parallel lines cut by a reversal are parallel. Good. Okay. What do I first then have to do with this? Plug in 10 for x. So I have 3 times 10 plus 4 equals, and 4 times 10 minus 6 equals. (34) is the bottom one. So because alternate interior angles are congruent, two lines cut by a transversal are parallel. And what we want to use for this is the converse of the alternate interior angles postulate. Postulate or theorem, I don't remember which. Okay. Does that make sense? Yes? Okay. Now, because your thinking is right, come back to this question. Are those alternate interior angles? No. What are they? They are corresponding angles. Okay? Are they congruent? Yes. So what theorem or postulate am I going to use? Converse of the corresponding angles postulate. Okay? They could also, I mean, they might give you something like this, though, and say angle 1 and angle 3 are congruent. That would be the converse of the alternate exterior angles theorem, right? Those are kind of the main ones. We've already looked at alternate interior, we've got alternate exterior, and we have corresponding. Those are your 3 main ones, okay? You need to be able to see those. All right, number 10. Good, I'm glad we'll get better than halfway through this. Okay, they're going to give you a triangle, something that looks like this. Okay. They're going to say find the area. Base times height divided by 2. Very good. You start with the formula. What is the base? 16. What is the height? Divide by 2. So you have everything there. Okay, 16 times 22 divided by 2. I'm going to take your word for it. 176. I don't know. They don't give you, we would say square units. Okay? Should be really easy. Okay, 11. And I don't know, there may not even be 20 questions on this test. Let me check real quick. Oh, there is. Okay. Okay. They're going to give you an equation. They want you to write it in slope-intercept form, and then they want you to identify what the slope is and what the y-intercept is. So somebody give me a number. All right, 7x plus, let's see, give me another number. 5y, equals, give me another number. All right, let's say 40. Okay, we want to write that equation in slope-intercept form. How do I do that? You need y equals, okay, give me the whole equation. Y equals mx plus b. And just so we're clear, what does the m stand for? Slope. Not mx, just m. Okay, so if they ask for the slope, we're not going to include x. Okay, what is the y-intercept? B. Okay, all right. So if I want to get it in this format, what do I have to do? Get y absolutely 100% by itself, not y and its coefficient. I mean just y. So what needs to move over to the other side? How do I move 7x? All right, subtract 7x from both sides. All right, so I've got 5y equals negative 7x plus 40. Divide the 5. What all gets divided by 5 on the other side? Just 40. No. Everything gets divided by 5. The same way if I multiplied across the other side, everything would get multiplied by that number. All right, so whenever we're adding and subtracting, we only add and subtract from like terms, but when we multiply or divide, we multiply everything and we divide everything, okay? All right, so we get y equals, what is the slope here? Negative 7/5, right, because it doesn't reduce. But can I reduce 40 divided by 5? What does that reduce to? 8. All right, so this is part 1. All right, we got it in slope-intercept form. Part 2 is, what is the slope? Negative 7/5 is the slope. Okay, in part 3, what is the y-intercept? 8. Okay, that's all 3 parts. All right, doable? Okay. I think we can get at least one more done. 12. Okay. All right. They're going to give you 4 coordinates. They're going to want you to classify the figure. 1, 2, 3, 0. 1, negative 2. And negative 1, 0. This is one where I would suggest that you get a piece of graph paper at the beginning, because why would I want to use a piece of graph paper rather than something like this? Okay. Now, I do want to be clear that on this question, I believe the answer is square. I believe it is. But here's the thing, is that if I'm going to prove this as a square, I have to prove a couple of things. Okay? I have to first prove it's a rectangle. Okay? How do I prove something is a rectangle? No. I mean, that would make it a parallelogram. I want to first prove it's a rectangle. Okay? And by that, a rectangle is a quadrilateral with one right angle. Okay? Because that's going to force right? It's going to force everything else to be right angles. So one right angle. Okay, I'm basically telling you what you need to do on this question. In order to prove that it has one right angle, I need to show that the two sides that meet have opposite reciprocal slopes. Okay? Do you guys know what I mean by that? That means if, let's say this line is, let's say it's going down 1 over 2, then this side, in order for that to be a right angle, would have to be going up 2 over 1. Does that make sense? All right. Now, the second thing, before we close, is I would, in order to prove it's a square, I also need to prove that it's a rhombus. And a rhombus has 4 sides that are all the same length. All right? So 4 sides, same length. So I need to prove the lengths of those 4 sides, which we have the distance formula where we can do that. So this is actually a much longer question than it looks. This may be the hardest question on the test, okay, in order to actually get credit for it. Okay? All right, we'll stop right there.